Unit 3 Chemistry, Chapter 4, Part 1, Redox Reactions. Now this should be revision from Unit 2. Let's see how much we remember. What is a redox reaction? It's any reaction where one of the reactants loses electrons and the other gains them. Okay? Those two things have to happen simultaneously. And whatever is losing electrons, the process of losing electrons is called oxidation. The process of gaining electrons is called reduction. This is to help you remember it. Oxidation is loss, reduction is gain. Oil rig. Okay? The oxidation and the reduction have to happen simultaneously. Electrons can't just hang around on their own. Yeah, they have to be bonded to something. Okay. Sometimes we don't see the movement of the electrons in a physical way. Sometimes what we see instead is a change in the charge, which means a change in the oxidation numbers. So an oxidation number or oxidation state, same thing, is when the effective charge on an atom is measured. And if that charge over the course of a reaction goes up, then oxidation occurs, because remember, electrons are negatively charged. So if you lose something negatively charged, you become more positive, so your oxidation number goes up. If you gain electrons, then your oxidation number is going to get more negative, it's going to go down. So a decrease in oxidation number is reduction. Okay? We use oxidation numbers because in covalent molecular compounds, we're not really seeing the transfer of electrons. What we're seeing instead is a change in how those electrons are shared. Okay? We can work out those oxidation numbers using there's a few of the rules, but they are quite simple. Rule number one which quite often trips people up. Remember, if it's a free element, the oxidation number is 0. So if it's just oxygen, O2, or if it's just nitrogen, N2, or if it's just magnesium, which would just be Mg, then it's got an oxidation number of 0, because it's got no charge. For a simple ion, and here we're talking our group 1, group 2 metals, also our group 17 non-metals, some of our group 16 non-metals, yeah? The oxidation number is the same as its charge. So we know, for instance, potassium has a charge of +1, its oxidation number is +1. If it's a transition group metal, we know that they have a variable charge, but whatever their charge is, their valency in that compound is the same as their oxidation number. So if you've got Fe2+, it has an oxidation number of 2+. If it's Fe3+, though, its oxidation number is now 3+. That may be indicated to you by the name, or it may be indicated to you by the formula in the compound. It won't necessarily tell you, you've got to work it out. Then there are some other things that we can use to work out what everything else is. So fluorine, most electronegative element there is, always has an oxidation number of -1. Hydrogen is almost always +1. The only exception to that is if you see it combined with a metal, just a metal, and nothing else. So we call that a metal hydride. So like NaH. Now Na is a simple ion, got a charge of +1, so it has to be +1. This whole thing, we can see, has got no charge. So we know that this charge of +1, plus whatever hydrogen is, has to have an overall charge equal to 0. So we know hydrogen, therefore, has to be -1. Oxygen is almost always -2. The exceptions are peroxides. H2O2 is pretty much the only peroxide you're going to see, and in that compound it is -1. And in F2O, because fluorine has to be -1, and the overall charge, look at it, no overall charge, it's 0, so the oxygen has to be +2 to balance that out. Okay, so as we've been looking here and here, when the compound overall is neutral, has no charge, then all the oxidation numbers have to add up to 0. If it's a polyatomic ion though, something like sulfate, SO42-, then all the oxidation numbers have to equal that charge. So SO42- has to have an overall oxidation number oxidation charge of -2. If you look through, you'll see that all of these have got a sign. That means that the sign has to be there. Leaving a sign off does not mean it's positive. Leaving a sign off means you forgot something. Okay, it is absolutely essential. One more definition. Oxidizing and reducing agents, sometimes called oxidants and reductants. Substances that cause oxidation to occur are oxidants. It itself is normally reduced. So it makes something else be oxidized. Yeah. So in order for something else to be oxidized, we have to take its electrons away. The oxidizing agent takes those electrons, and by taking electrons, gains them and is reduced. The opposite is true for reductants. Reductants cause reduction to occur, so they are themselves oxidized. I did not make these terms up.